What's up, YouTube? Welcome to this next episode on So You Think You Know C Sharp. This one's going to be short and sweet. It's simple things, but nonetheless, I think will be an eye opener for some of you. And it's worth making it as part of the So You Think You Know C Sharp series. And we're talking about constants. I think a lot of these topics are like, really? Is that what I need to be watching right now? Yes, constants and default or optional parameters and default values. They're similar, so I've kind of put them together. So the first thing I want to clear up is constant variables. Did you get that? Yes, I hear people say constant variables. They're not variables. They're either constants or they're variables. Variables vary. Constants const. No? Variables certainly vary, but constants are constants because they don't change. So how can a constant be a constant variable? And behind the scenes, and I'll show you, they are not variables at all. So to call them constant variables in itself is not a good idea. Just call them constants. So declare a constant or use a constant, not a constant variable. All right. So what I've got for us today is I've already pre-done the coding, so it's going to save some time. So this is going to be a really short video for those of you who don't like the long duration ones. You'll love this one. It's quick and dirty. I've got a solution, Visual Studio solution here. There are, in fact, in the solution, there are two projects. One is a console application over here, and the other is a library application, right? And it's not that it's required for constants, but I want to show you a problem, a potential problem with constants and default parameter values that I don't think a lot of people think about. I hit upon this many years ago. It was one of those head-scratching moments I wish I never had, but I learned my lessons, and since then, I've seen other people fall in the same trap. So here's what happens. What I have in the constants library here is, let's look at the first one, the constant. So I've declared in a public static class a constant value. So the message hello, and it translates to or is equal to hello world, right? It's just a constant here in a static class. Now the way I'm using this here is let's look at this one line here. In fact, let's just comment this out. All right, so I'm using the constant value here. And if you look at the output, this is exactly what we would expect. Right? We're expecting the hello world to be showing up here when we use that constant. All right, but let's see what's happening behind the scenes. So what I'm going to do is I'm going to now modify this value here. So let's say I'm going to call it, and before I do that, let me also show you what I plan to do once I've done this. So if I look at the folder here in the debug bin folder, the constants lib assemblies here, and then there's the exe over here. So this exe is the console application, and the constants lib, of course, is the library project that we have. So because I'm modifying this here to say like that, I'm going to actually delete this assembly, right? And I'm going to rebuild this assembly. Oops, what did I do here? All right, and if you look back here, you'll see that the new version has appeared over here much later, 1 minute later than that one. All right, I run this app, and you still see it says hello world. Are you surprised? Are you shocked? Did you fall off your chair? This is what happens, and it's not always this is what will happen, but you have to be aware of what's going on. So in case you do hit upon this kind of an issue, you don't get stuck scratching your head like I did many years ago. So here's what's going on. If I look at I'm going to use ILSpy again, just to show you what's going on internally, or after compile, and I'll open first just look at the messages part here. You can see that this class has this declared here. There's a typo there. But if I look at the console applications main method, there are a few things that will surprise you, I think. First of all, what the heck is this hello world doing here? We've declared it in this class here, but we've changed the value, but nonetheless, this is showing up as hello world. And of course, when it prints it out to the console, it prints out hello world instead of what we were expecting, which is the new value, hello world, how are you? How are you doing, right? So the question is, why is that? And what's really going on? At compile time, constants are baked into the call site. At compile time, constants, or the values of constants, are baked into the call site. The call site is wherever you're using the constants. So here, for example, in our main program main, this is the call site for that constant. So rather than leaving it as some sort of a static property of a class in this case, at compile time, the value from the constant is baked into the call site. So that's what we're seeing over here. We are seeing in our main program, we are seeing that this value has been baked in here. Now, if there were 1,000 places in which you use this constant, that value will be baked into each of those call sites. Okay, that sort of makes sense. But why? Well, because of an optimization, and also because they're not variables, then they don't want them to be varying at some point. So rather than leaving it as a variable somewhere, you just take the value and you bake it at the call site. That may not be an issue until the constant is coming from a different assembly, which is what we have over here. The constant is declared in one assembly, and the value is being used in another assembly, and potentially there could be 10 other assemblies, including the assembly itself. So the issue occurs when you say, okay, let's change the value of a constant, at compile time. Maybe for whatever reason, your value has changed. And you say, well, I've got it all defined in a constant. So I can go into the one place and I can change it. And voila, the entire application will start working with the new value. And that's what doesn't happen. So keeping in mind that the constants at compile time are baked into the call site, you will understand that unless you rebuild all assemblies that are dependent on the assembly that has the constant declared, the new value is not going to be baked into every call site. And what I did here was, when I made the change to this value here, for example, let me just do it again. I build this over here. Now you can see that if I would reload this, it's got the fixed up value, right? But I built this, and what happened is over here is as well, the new value has come in here. And so if I were to run this application now, you'll see the new value, right? So to reduce the problem, what I did was, let's go back. So let's say hello world 2, like that, hello world 2. Now, when I build this, I only build the actual assembly. I don't build the entire solution. So when I build the actual assembly, what's happening is, and I move the newly built assembly into this folder, in the bin folder of this application. So you get the new version here. When I run it, even though you get the new version, it has not changed this value here because we have not rebuilt all dependent assemblies. And you have to build dependent assemblies when you change constants. Just remember that. Don't ever think you can just take the newly compiled assembly that contains all the values for the constants and deploy it to some production site and everything's going to just work. It's not going to work. Now, there was a time many years ago, we would do that to sort of save space and upload times and a bunch of other things. We would just deploy the assemblies that changed. And that's where this problem started to occur. So constants at compile time are baked into the call site. And so if you change the value of a constant, you must rebuild all assemblies that depend on this constant value for the change to take effect. Otherwise, you'll be in big trouble. All right. Now, the second feature we're looking at today is the default values. So I have a class here in the same assembly, in the libassembly, constants libassembly. I have a tax calculator class that's also starting in this case. And then I have a method called calculate. And this calculate takes 2 arguments. One is the taxable income, and the other is a percentage. And it has a value of 30 here by default. And that's a default value, right? So I do some math, simple percentage, and I return the value. So at the call site now, I'm calling this method with that optional value left alone, 30, right? So when I run this application, you'll see Oops, let me just show it this way first. For $70,000, 30% is $2,100, right? That's the correct value, $2,100. All right. Now, let's say at some point later in the lifetime of this application, I change this constant to be 50, right? And once again, when I build this, I just build the assembly, not the entire solution, right? And then when I run the application once again, you'll see it still shows me 21,000. Huh? What happened? This is another feature where the default value, see the C# language has not, well, let me clarify. The runtime has not changed. Pretty much .NET 2.0. Now optimizations have occurred and a bunch of other things have occurred, but from a language perspective, nothing has really changed. So when we get a new feature, it's not necessarily a runtime feature. The runtime doesn't understand default parameter values or optional parameters. It doesn't know that. The C# compiler at compile time does this feature called lowering. If you haven't seen that video of mine, please take a look at it. I'll put a link to it up here. C# lowering, lower, higher, and lowering. And C# lowering handles that situation. So at the time of compilation or at the time of lowering the C# code from a higher language feature to a lower language feature, it takes that 30 and it bakes it into the call side, just like the constants. If you were to look at the IL for this application, if you were to look at the IL code for this, let me refresh, reload, sorry. You'll see it has baked the value of the constants at the call side. And actually, this might be easier to look at it as C#. So what we've done is we've compiled this code. We're looking at the IL for that, and we reverse engineer it back to C#, and that's what you're going to see. So what you're going to see is this. The constant is baked at the call side. It's not using the constant itself. It's just baked the value at the call side. And this is done the same for, what happened to the 30 here? For some reason, not showing the 30. It should be showing a argument 30 for some reason. It's not showing that, but you can see in the IL it's there. Or maybe is that a, no. You can see it here. It's got the 70,000, sorry. It's got the 30, and it calls it with the two arguments, right? The two floats. So I guess the reverse engineering is not doing a really good job of depicting that. The other thing that you should notice here in the tax calculator's method here is, again, in IL. This second argument, the percentage, is marked with the opt attribute. So this is a metadata, if you will, in the assembly that says that's an optional argument. But at compile time, that takes that and puts that value here. So whatever the value is, in this case, it bakes that at the call side. So since we didn't rebuild this assembly, we're seeing this as 30. If I go back in here, and now open up ILSpy again and reload the assembly, wrong assembly. You'll see here now it has taken 50 instead. I don't know why the C# side is not showing that. It should have shown it. Well, there it is now for somebody who's doing it. That's funny. All right. So now it's baking the value, the default parameter value at the call side. So just like with constants, the same error or same problem will occur here with the default parameter values. If they are in different assemblies being used by things in a different assembly, then you need to rebuild all dependent assemblies for the effect or the value effect to take over or take place, because at compile time, it bakes the value at the call side. Now, this funny story about the default parameter values. Before we got it in C#, I said, man, if we just had default parameter values, it would be so much better than doing this overloading thing, right? Because that's the other alternative was you have overloaded methods with different sets of arguments and so on and so forth. And when you called one overload from another overload, you could default the value in that method. So you got the default and the optional, if you will, right? And then finally, we got this feature. I forget what version of C# this was, I got really excited about it. And for whatever reason, and I'm not sure exactly what happened, and I didn't hit upon this problem before I actually had the problem, made this choice or change of heart, if you will. I just never used that feature again. I have never used this feature in anything production, or even generally, I just don't think in those terms of optional values. I will continue to do the overloading methods if that's appropriate, if that's what I need. I think overloaded methods convey your intent much better than optional values for whatever reason, even though the net result is the same. When I look at the code, I'd rather see 2 or 3 overloads with the different optional argue with the different parameters and the default values than just have one method that has all these multiple optional values. Right? So that's the part that I didn't like. So I've actually never used it, even though I was waiting for it. When it finally came to us, never used it. Now, whether I changed my programming style or ideas about programming since that point, from the time that I had the desire to the time we got the feature or not, I'm not quite sure. But till date, I have never used that feature. Now, constants is a good feature. Of course, it's very, very clear about what your intent is. And there are optimizations in that, even though these are values, like this is a literal that's baked into the call site. So it's not some optimization, but it's conveying intent very clearly. These are constants. Now, of course, with constant, make sure you use constants that are truly constants. And that's the other thing. So in case your values could potentially change, I'm not saying they would change once a year, maybe once in 2 years or 5 years. I'm talking about like if they change every month or week or something, that's not a constant. Right? So make sure you use constants as truly constants. All right. As I said, this was going to be a short video. I hope you enjoyed this. I hope you learned something new and fascinating about C#. And I will see you next time.